Welcome to a new season of the Science Olympiad structural event. This year we're going to be building towers. If you are brand new to tower building or balsa building in general, I'd recommend you start with some of my other videos to learn about basic build techniques like gluing and material selection. I'll leave some links in the description that can help you get started. The rules for this year have now officially been released. You should definitely study the rules carefully for all the events you are competing in. It's good to know them like the back of your hand before your first competition. For the purposes of this channel, I will focus on the design aspects of the rules, but it's very important to know everything about what is required to compete, including things like the check-in procedure, safety rules, submitting a logbook, and what the test day procedures will be like. If you've read through the design part of the rules, probably the first thing you notice is that you'll have to choose between building a tower that attempts to get the bonus or not. In this first video of the season, I'll explain in detail what that means and talk about how you might go about building a tower to each design. I will also share my 3D printed jig files for both versions, so you'll have a nice starting point if you'd like to try either one. I plan on releasing 6 videos over the next couple weeks that should help you get a jump start on the season. After this introduction, the next video will show my first 2 builds of the season, where I build and compare a non-bonus and bonus tower built out of essentially the same material choices. After that, I will show a more refined non-bonus Division B tower that would be a good baseline to compare your early builds to. Then I will see if I can build a tower to the bonus design rules that competes with my best non-bonus tower and what the implications are for choosing that design route. Finally, I'll have 2 videos where I show my initial Division C build and then a more refined version of that build to give a nice early target for high school teams to compare against. Let's start with the basics of the testing stand. You can see here in the rules that there is supposed to be a 20 centimeter square hole in the middle, but unless you are holding competitions with your practice test stand, you can get away with a much smaller hole and just mark off a 20 centimeter square like I have done here. The design rules state that to achieve the bonus for the tower, not only does it need to hold the entire 15 kilograms, but the base of the tower needs to span a 29 centimeter diameter circle. I was able to adapt my test stand to show that by cutting out a 29 centimeter diameter ring from graph paper and taping it to the testing surface. You might notice that I have tape all over the place here and might be wondering if that will get in the way. As it turns out, if we stick to 4-sided towers, the legs will always be in the exact same place for the non-bonus version, as we want the tower base to be as small as possible. I marked the green tape with lines to help align the tower during setup. The legs for a non-bonus tower will always go here. Because the bonus tower has to fit outside a 29 centimeter circle, it can be oriented in any angle, but I like to keep things consistent and have marked the test rig to always align them in the same place. The next thing I want to talk about is how important it is to have some kind of an assembly jig to aid in building your tower. I'll be talking about 3D printed jigs, but even if you can't print this, you'll want to build some kind of device to help you assemble your towers. All of my initial work was with the Division B rules, which state that the tower must be at least 50 centimeters tall. But as you'll see later, you can just scale the exact same 3D jig by 120% in the Z direction to get a perfect Division C jig. My printer is not big enough to print the entire jig in one piece, so I have split it apart into 3, a bottom, a middle, and a top. I have had a lot of success in the past using PL3 construction adhesive to glue PLA pieces together, and here you can see I glued the bottom 2 pieces together and then the top piece. It was only after things had dried and I took a close look and I learned a hard lesson that it wasn't completely flat. I decided that that wasn't good enough, so I printed another complete set and took a different approach to combining them. What turned out to work extremely well was to just use masking tape on the outside of the parts to hold them together. This made sure that the gap between the pieces was as small as possible. There was no chance it wouldn't be level like the previous one. Here you can also see the finished non-bonus jig sitting on my test stand to get a feel for how the finished towers will be and to verify that it's the correct size. I followed the same procedure for the Division B bonus tower. You can clearly see it as much larger base, and when the final assembled version is put on the test stand, we can verify it is also the correct size. Just a quick note on printing these jigs. They are big and take a lot of time, so be prepared. As you can see from these notes, it took just over 41 hours to complete all 3 pieces of the non-bonus version, and the bonus jig took over 63 hours at 10% infill. I used inexpensive PLA material for these prints, but it's still a non-trivial cost if you have to print a bunch of these, so you might want to share them across your team if possible. Here you can see both jigs side by side for a comparison and what they look like with the complete view of my test setup, so you can get a feel for how big the towers we are building will be. Like I briefly mentioned before, it is very easy to take the Division B jig pieces and scale them to make them work for Division C. I designed the Division B tower to be 50.5 centimeters to have a small extra height buffer for the rules. Most 3D printing programs can take any STL file and scale it in any direction before printing. Make sure you uncheck the uniform scaling box and only scale the Z direction by 120%. Technically, you could scale by slightly less than 120%, as that would give you a 60.6 centimeter tower, but I just kept my example simple. Feel free to scale these jigs down a tiny bit if you want to leave yourself less of a height buffer. Here is the result of a non-bonus Division B jig scaled by 120% in the Z direction to make a Division C jig. Again, I just used masking tape to assemble the pieces together. For reference, this jig took over 48 hours to print all 3 pieces using the same settings as before. I will put links in the description of this video for all 6 STL files I'm using here. In the next video, I'll actually start building some towers with an initial comparison between a bonus and non-bonus design for Division B. My first attempt uses basically the same materials for both, so you'll be able to see how much different these designs actually are. Thanks for watching, and feel free to reach out to me if you have any specific questions.